and 9, 8, 7, 6, Karsten, 5, 4, 3. Ooh, hey, it worked. Hello, everybody, and welcome to Technology Deep Dives at IETF 119. These are a series of talks on sort of like foundational protocol technologies, especially the sort of things that people build other protocols on. So we've had some on things like DNS, and now we're going to have BGP for protocol developers. This is part one of a two-part series. The other one will be held on Thursday from 5:45 to 6:45 p.m. local time in the Plaza Terrace room, and that one will be even more exciting. So make sure you come to that as well. Take it away.
As Jeff says, there's nothing more exciting than BGP. So I'm John,
And I'm Jeff.
and yeah, so it's, and you have the clicker, right?
Yep.
Cool. So this is kind of a funny talk in that we're not going to teach you what a protocol is. That's because it's for protocol developers. And we jump in slightly in the middle, but hopefully not too much in the middle. There's a lot to cover, but on the other hand, how interactive do we want it to be?
Well, so we're on a pretty tight time. One of the things we want to offer is that once we're done with the hour here, there's nothing else in the room as best we know. Feel free to come on up. We're happy to chat with you afterwards. The goal of this talk is to talk about BGP as a protocol, the things that make it useful. It's not meant to be comprehensive. It's not meant to hit everything you'd get out of reading all the RFCs. It's to give you a core flavor of what the protocol does. And as we see on the slide here, this isn't talking about any specific implementation. This isn't about internet routing as a whole. And this is not a deep dive around security stuff, although we'll talk about that a little bit on Thursday. So in terms of what it actually is about, this is about high-level protocol elements. Pretty much everybody in this room probably has written at least some as a PDU. So this is not going to be that.
So BGP is a path vector protocol, which really means it's a distance vector protocol, which really means that it's just RIP. And there are a lot of people in here who really don't need to be at this talk because you already know everything there is to know about BGP, but you're just here to throw peanuts at us and make sure that we stay honest. So I'm going to assume that everyone knows enough about what it means to be a distance vector protocol or a Bellman-Ford protocol, and that's all we're going to say about it here. So it's in 4271, and then a cast of thousands of other, or at least dozens of other RFCs, and it's the internet routing protocol. The main abstraction unit is you build, you have ASs. Probably everyone in the room has heard of ASs, I hope. And you can abstract the internet as a bunch of ASs that talk to each other, and you can look inside the ASs and look at the routers that make them up. It started out as a IPv4 only protocol because IPv4 was the only thing. And it turned out to be extensible enough that we could wedge IPv6 into it, and then we could wedge a lot of other stuff into it, and we just keep wedging things into it over and over again. And Jeff did a very nice talk on it, and you can see it at that URL there.
Yep, in terms of wedging stuff in, that's a lot about what our Thursday talk is about.
Oh, look at that, we left my tag in there.
I think we have an old version.
So yeah, what's an AS? It's a collection of resources that are run by the same administration. It's defined by an AS number, which is a 32-bit thing that you get assigned to you. And there are two basic flavors of BGP. There's iBGP, internal BGP, that operates inside the AS, and there's external BGP that operates between ASs. Generally, the idea on iBGP is that you want to have consistency between all the routers in your AS. Generally, the rule on eBGP is that people do policy and pick and choose between what their neighbors send to each other.
Yeah, and sort of building on that point, you can think about the iBGP piece, very much like this is your IGP flavor of BGP. It's very boring, or at least we try to keep it as boring as possible. eBGP, as John said, is all about policy. BGP is actually a very straightforward protocol when you work from the RFCs. Most of the challenge for BGP is making it scale and providing mechanisms to operate it with some, simplicity. So most of the headache for BGP, like I said, is how to operate it, how to make it scale. We're going to talk in this discussion about what the state is that we're passing around. So the key concepts in BGP that are important is that we have network layer reachability information, NLRI, basically the thing you would normally think of as a route. But for BGP, an actual route is a pairing of an NLRI plus a set of path attributes. The path attributes are a set of properties that go along with that destination. We're going to talk about what those things are. BGP is a stateful protocol. Unlike RIP, you're not going to get the same message over and over again every 30 seconds. You're going to hear it once, and you're expected to remember it forever. And that impacts an awful lot about how the protocol needs to pass stuff around. This is actually one of the things that makes it popular. The gotcha, of course, is that if you lose something, either because of a bug or because you've intentionally thrown it away using policy, well, you have issues. There are mechanisms to get stuff back. And again, that's part of the discussion about how BGP has evolved.
Just to add, there are mechanisms to get stuff back if you know there's something you need to get back. The protocol will not be kind to you, though, in terms of telling you that you lost something. Many of our other protocols do have ways to notice that you've lost information. BGP is not such.
Yeah, the easiest way to think about BGP at a high level, this is one of the things that's made it an attractive target for a lot of people to do interesting things with. It's effectively a key value protocol. If you think about it that way, a lot of BGP seems simple, and that's what gets you into trouble sometimes.
Right. So anybody who has done anything with BGP for more than a few minutes has talked about update messages. And that's, almost the entire life cycle of any given BGP session is just a whole bunch of exchanges of update messages. It's what you carry routes around in. And you either advertise routes, which inject new state, or they change state, or you explicitly withdraw routes. A lot of the effort in building BGP extensions has to do with trying to make sure that you maintain packability, meaning that you can if you have multiple NLRI that all share the same set of attributes, you want to be able to gather them together in the same update message. This ends up making a big difference in efficiency.
And the efficiency, this is one of the hidden messages behind BGP. The reason why you care about packing is that you tend to see the CPU load for BGP mostly on a per update PDU basis. Most of the work is taking your path attributes and building your data structures and doing stuff with them. So there's a good incentive to try to amortize that work. In terms of that work, well, you've done all the work for parsing these things. They have to go into something. Well, sort of in OSI type speak, because that's where we started this stuff. BGP routes go into the routing information bases, the RIBs. The RIBs are keyed on those NLRIs that we talked about. Again, this is why it looks like a key value protocol. And we have 3 views that BGP tends to use for things. And if you look at how we've classified things later over the years, there's sort of 5 logical views of a pre-policy, post-policy flavor. But the important pieces are there's a ribs in where you store the routes that you've been given. You have the loc rib, that's where you actually select the route, which we'll be talking very briefly on, but not as much as deserves in the topic, as the active route that we've picked. And then when you go to distribute the thing, you have a ribs out view.
Okay, so again, it's a super simple protocol. It's connection oriented. It's all configured. It runs over TCP, although there are some proposals to run over other transports, but they all have to look kind of TCP-ish in terms of their semantics. Yeah, we exchange PDUs over the TCP sessions.
Yep, and one of the challenges for BGP as a routing protocol, especially if you're sticking to original specs, the timers are slow because this is running on top of TCP. You can't count on the things going fast. It's at the order of seconds. If you want something faster, you're going to have to augment with something like BFD.
So yeah, TCP, like we said, what's good about that? The founding parents of BGP didn't have to invent their own transport and transport semantics. You can, just all the good things about a stream-oriented protocol. The bad things are every BGP developer has to eventually become, somewhat expert in TCP and all the things that make it interesting in edge cases. And every BGP implementation has to do its own framing, which is kind of a pain. Yeah.
And if you attended the IAPG talk earlier this morning, talked about DNS and what transport it actually impacts that. It's very much the same here for BGP. The actual TCP properties you're getting, how the network's behaving, what packets are getting dropped, makes such a huge impact to how the protocol actually works. Again, BGP at the top level is very simple, but this is a sharp edge that people run into as problems. In terms of once you've actually gotten your session up, you can swap messages. BGP calls them messages instead of PDUs. Everybody starts off with a common header format, which you have this big marker thing in the beginning here. It's like, what's this thing for? Well, BGP is a protocol that's evolved over time. One of the things that you have to watch out for, and this is true of most IETF protocols that have lived for a while, there are strange things that don't make sense based on the text, but are really vestigial components from how the protocol evolved. The marker here originally is where security information was put in as one of the earlier proposals. These days, nothing interesting goes in here. It just gets a bunch of ones. But that said, we've actually managed to have BGP evolve, and we're up to BGP 4, and we've only burned 5 message types.
Right. So yeah, the lifetime of the session is you come up, you exchange a pair of opens, the endpoints tell each other their AS numbers, and a hold time. The hold time is basically a bid for how fast you need to get keep lives, which I think we come to in a minute. We don't call it a router ID in BGP. We call it a BGP identifier, and it's formally just a arbitrary 32-bit integer. And then there's this thing called optional parameters. Do we have another slide that dives down in there?
Yeah, we actually dive into the open message here. So, this is, again, very boring. This has roughly been what BGP's been since version 1, with very, very minor changes. As John's saying, these optional parameters that are glued down here, this is an example of something that was designed in from the get-go, but didn't really have a solid use case. Extensibility was built into the protocol without an idea of exactly what we're going to use it for. The very first optional parameter that went in there was originally the security thing that populated that marker field we were just talking about. The thing that gets used in there right now is BGP capabilities, which we'll talk about a little bit later.
Right, so I think we already kind of talked through the beginning of that. There's a state machine. We're not going to try to explain the state machine. It has lots of pointy bits and sharp corners, and Jeff worked on it a lot, and so did Sue, and so I shouldn't be talking to it. They should be.
Well, and actually the useful thing out of this is, if you look through the history of BGP, partially see this presentation I gave for NLog, the state machine in 1771, was very simple. There's a small number of states. The transitions were very straightforward. And as part of the process where we're trying to actually flesh out the RFCs, we found a ton of corner cases. You wouldn't think there'd be that many things, but people kept on finding these sharp edges. The state machine therefore grew in complexity. So we try to actually cover a lot of these things inside of 4271, but it still doesn't get it 100% right.
So yeah, TCP turns out to not be really the right tool for keeping track of whether the thing on the other end is still alive, at least not if you're trying to route a network with it, because having it go away for a few hours is not okay. So we just use this very crude approach of sending keep alive messages, and actually the keep alives only need to be sent. Basically, anything that happens on the session resets the whole timer. So normally, if you're exchanging a lot of routes, the update messages are quite sufficient to keep the keep alive going. If things get quiet, then you send essentially just empty headers.
Yeah, the important thing to take out of this is a hidden property. BGP is a slow protocol. You're not expected to necessarily worry about how quick things can come up or come down. You're trying to pass data around, and you need to expect that it's going to take it a while to notice that something has changed.
It occurs to me, by the way, that we don't talk in this presentation at all about the interaction between BGP and the IGP. That's important, but not covered here.
Now, once the session is up, you have to figure out what to do to take it down. Clearly, if the TCP session just goes away, that's one thing that has to be handled. But if you're intentionally trying to signal that you're going down for any reason, one of the messages that we pass around is the notification. Contains a error code and a subcode, and it contains a whole bunch of data that might be useful for things. For the most part, notifications are very boring. It's a bit of diagnostic information about why the session went down, and for 90-something% of the types, it has no impact on the state machine. There's a small subset of things like graceful restart and other things that do actually care about this, and things like version negotiation. For as much good as that's done us, BGP's version 4, it stayed that way for a very long
time. Right, so yeah, as mentioned earlier, all the good stuff is really inside the updates. Yeah, RFC 4271 itself only carries IPv4. So we will cover that first and come to the extensibility parts in a minute.
Yeah, in terms of the actual message, one of the things that's noted here is like BGP carries, as we talked about in prior slides, positive state and negative state. The start of the PDU is the stuff you're withdrawing, the negative state, the set of path attributes, and the actual reachability, the positive state. Things to note here, you can put positive and negative state within the same packet. The packability is part of how we get through here. One of the things that's sort of annoying, and again, this is all small, sharp edges that bite you when you're not used to things, and we do better these days. BGP is not 100% a strict, rigorous TLV protocol. In this case, some of the field links are implied. So you have to realize that the math is not actually done for you in some spots.
Yeah, there are actually a bunch of places in BGP where when you look hard, you can tell when different pieces were developed because people were more or less strict about really trying to squeeze bytes. So anyway, the prefix encoding should be familiar by now. It's pretty much universal across almost all of our protocols. One thing that tends to bite implementers is you're supposed to ignore the trailing bits. You should really make sure that you coerce them to 0 and don't just count on the sender to send them to you as 0, or otherwise you'll be unhappy at some point.
Yeah, one of my favorite bugs is somebody fails to strip the trailing bits. The reachability is technically the same, but you've stuck it into your favorite Patricia tree data structure, and well, things don't index correctly. One of the sort of interesting irks about prefixes encoded in BGP, effectively it's a stream of these things. They're not separated individually by separate TLVs. They all appear just back to back. And as we talked about, you need to ignore the trailing bits. This means that we have ambiguities. And these ambiguities are things that can bite us at various points. So if you have 2 byte patterns that have the same destination, if you ignore the trailing bits, but different bit patterns, well, the spec doesn't really give you a lot of guidance as to what to do about that sort of thing. And the bigger problem is when you actually have this stream of prefixes, the only way to tell if the thing is properly formed is try to parse it. If you're lucky, you're going to end up at a proper byte boundary for the next envelope in the packet. The side effect of this is that if you have a malformed set of data inside of your NLRI, but it successfully decodes, the protocol looks like it's working, but you're sending around trash. And this is one of the things that makes bugs very hard to diagnose. One of the things that would have been very nice to have added in the protocol would have been have at least like a count of the number of prefixes as a, there should be this number of things present.
Next time. So, right, BGP in the base spec has just 7 path attributes. They're very simple, especially because a bunch of them are vestigial. For example, origin just has 3 possible values. It could be from the IGP. It could be from the EGP protocol, believe it or not. And it could be incomplete, which means, I don't know. So this attribute is almost completely vestigial. It's just, in effect, the only thing it's good for is it's kind of a coarse 3-level metric that people use sometimes.
Yep. Can be useful for tie-breaking routes. There are actually more than one person in this room that actually has been in an environment using EGP. I am not one of them. Probably the most popular attribute out of BGP that most people are familiar with is the AS path. We talked about earlier that BGP is a path vector protocol. Well, the vector of paths in this case is the autonomous system numbers. And the main purpose for this thing from the get-go is this is just simple loop detection. If your AS number is in the path, it's a loop. Very easy to decide if you're dropping things. But very early in the history of BGP, it branched from this is just a thing used for loop detection to you also use it to provide one of the default ways of choosing routes. I'm going to pick the thing that has the shortest number of ASs, and the AS path is one of my criteria. These things are only added when you cross an eBGP boundary. One of the things that's complicated about this as a feature, this is actually more than one thing. An AS path can contain multiple types. We have sequences, we have AS sets, which is mostly deprecated. We'll chat about that a little bit later. And as a coarse metric, it works okay. And if you're a service provider, you start caring about AS path length and your connectivity to various providers, because this can actually impact whether you receive traffic or not. Again, BGP is a simple protocol. If you're trying to make money with this thing, you want to be densely connected, therefore a short AS path.
Yeah, so the next hop is what it sounds like. It's when you're forwarding toward this route, what's the next hop? So the most common use case on eBGP would be a first-party next hop, send the packets to me. I can use a third-party next hop on eBGP, send the packets to Jeff. In IBGP, commonly, next hops might be third-party, especially when route reflection is involved, but we'll get to that.
So BGP also adds in two types of attributes that are metric type of things. This is not strictly tie broken on the AS path length. The first one is this thing called a multi-exit discriminator, the MED. And both of these types of metrics are 32-bit values that have opposite importance for which is more important. MEDs you want to have smaller. And the idea for this is between two eBGP speakers for this same AS, you want to prefer the exit that is got the lower number. Oddly enough, this is across the entire autonomous system. This feature causes more bugs in route selection than any other thing in BGP. So it's a lot of sharp edges here to be aware of.
Years ago, we tried to get rid of it, but it turns out to be beloved of network operators.
So you can blame the network operators for this, but in terms of your internal stuff, as part of receiving this, you're going to assign a local preference to it. For strange historical reasons, this value is pretty consistent across implementations, but a network is allowed to pick whatever magic value it wants to do. Higher number is better. I can do this one. Aggregation. Aggregation is a feature that seemed very popular at the time. So BGP started, 1 through 3, when we were still working on classful routing. BGP 4 is what actually got us to classless routing. And the side effect is, especially at the time, people cared more about doing programmatic aggregation. So one of the things you do when you're making a less specific route out of some set of more specifics, well, you have to figure out how you're going to handle the tie breaking for these properties. One of the things that went in there is that when you did the aggregation, you would throw all of the contributing routes AS numbers into a set. Now, you got all the nice loop properties of this. It meant that all the contributors did not actually get the less specific route. This helps for forwarding in some circumstances, but it also complicates things for the future. We're actually doing work to try to get rid of this thing because, among other things, it complicates BGP security features that we've developed since then, like RPKI origin validation. So we have sets as one of the pieces for this. Part of the signaling we add to this stuff is there's this aggregator attribute that says, I'm the one that did this work. It's only informational, not terribly interesting beyond that. Atomic aggregate, if you go reading through the history of things, this one, if you're trying to implement the protocol, it's very clear what it does these days, but if you're looking at how it evolved, you're seeing that this is actually quite a deep pain. So this is actually a history lesson in terms of a feature that started off with some reason, got complicated, and eventually got abandoned. That makes it difficult to implement the protocol. So in terms of protocol maintenance, this is an object lesson.
Yeah, so the encoding is fairly straightforward, but only fairly. You've got a, sort of your typical TLD look. There's a byte of flags. So there's the optional or mandatory flag. Everything you're ever going to add to BGP is optional. There will never be anything else that's mandatory that's not already in 4271. There's transitive or not transitive. We come to that in a slide or two. There's partial, which I don't think we cover, and we'll just skip over that. And then there's this really annoying thing, which is this was part of the byte pinching era of BGP, where the length field can either be 1 byte or 2 bytes, depending on whether that flag bit is set. It's just annoying.
Yeah, and as John mentioned, the irregularity of this is one of the things that makes writing parsers a little bit harder. So the gotcha is, the protocol's lenient. We follow the Postel's theorem here. You theoretically should absorb as many bytes as the field tells you. you're expected to try to be minimal. We have had bugs when people decide that this thing is less than 255, it should only fit into 1 byte, and they only decode 1 byte in the wire. So this is a case where paying attention to what the protocol actually says you're allowed to do and leniency can be very critical.
Yeah, so transitivity. This has been like the source of quite a bit of angst over the life of BGP. But it's also a source of a lot of the power. I guess with great power comes great ability to shoot yourself in the foot. Path attributes can be transitive or non-transitive. The transitivity that we're talking about is across routers, not across any higher abstraction units than that. If a path attribute is non-transitive, that means that the router that receives it had better be able to decode it and understand it. And if it does, then it'll do whatever the specification says it's supposed to do, including, by the way, transiting it. I mean, but which is sort of semantically regenerating the attribute, not passing it through. If it's a transitive attribute, on the other hand, if I, the router, receive this thing and I don't know how to decode it, and I say, oh, that's fine. I set the partial bit, remember that, and I just go ahead and pass it through as a bag of bits. This is powerful because it is actually what has driven a lot of the long life of BGP, because you can push in new features without having to forklift your whole network. But I think in maybe the next slide or so, we anyway, it can really lead to some fairly severe pain. Do we have another slide on that?
One step down, the
Okay.
only relevant thing to hear mention about the optional piece, as John mentioned, pretty much everything outside of a few attributes from 4271 are going to be optional. A few of them are mandatory. Mostly what this has done for us outside of historical nature has led to bugs. There's a lot of interesting security headaches that have popped up over recent times with people, being more or less strict about this sort of thing, based on what the RFC says. And the only thing this helps us with, it doesn't really help you to say if this is really, mandatory or not. You care that the actual data is there. The bit just is a vestigial thing that causes issue. As John's saying, we get to what does this transitivity do for us for adding new features.
Yeah, so the reason that we're still talking about BGP4 20 years later, or however long it's been, is because it's fairly easy to shove new stuff in. As long as the thing is transitive, it can go all over the internet, even though most of the internet doesn't know what the thing is. So, right, one of the, I don't know if it is the first example, but certainly the first well-known one is BGP communities, which are just bags of bits that you can write policy related to.
And one of the things that this is highlighting for BGP as a property, do you know about this thing? Are you ignorant about the feature or not? And it also gives you a sense of scoping for the protocol as well. And we get to all these fun pieces with transitivity as John's getting. If you're ignorant about the thing and you manage to pass it across some portion of the network that doesn't understand it, and then it pops out somewhere else, at a place that does understand it, and it's broken, well, the original piece of the protocol said, well, you just sent me a bad packet. I'm tearing down the session, which was penalizing the messenger rather than the person that actually caused the problem, perhaps far away. This is one of the reasons why BGP, from a security and a deployment standpoint, has been sort of scary, because when stuff happens, the blast radius is undetermined sometimes. This is one of the security discussions we regularly happen. We had a series of issues along these lines that eventually caused us to say it's time to change the core error handling for this so that we don't penalize the messenger. We have to decide what things are correctable and what to do about it.
Okay, what are we talking about here? Yeah, the decision process is super important and super fiddly, and we're not going to dive deep into it because of the super fiddly part. but in particular within an AS, especially if you're doing hop-by-hop forwarding, it's of paramount importance for everybody to be running the same decision algorithm. And it's unfortunately fairly common for people extending the protocol to think, oh, yeah, I just need to change the decision process a little bit for my new attribute, and to not really think through what the implications are going to be when that thing is deployed. So that's, I think, probably a fairly big hassle for both the protocol, the implementations, and the working group to like sort of come in at the last minute and say, this specification you wrote for thing foo, you didn't really think very hard about the decision process, and now we have to cycle it back through the working group another time or two.
Yeah, and part of what's being highlighted here is how difficult it can be to do incremental updates. When you're doing the new feature that's just carrying the new state, that's easy. And as we're going to get to when we talk about V6 and later, adding new things to carry, also not hard. Changing core behaviors, you have to do it within a scope so that it is consistent. And that means that you're not only considering how the feature is being encoded, which is most of what this talk is about, but also how it's incrementally deployed.
Okay, well, IPv6 was obviously sort of like the first big test of BGP's extensibility. If BGP hadn't been extensible enough to carry V6, we'd have BGP 5 now or something else, but it turned out that it was extensible enough. And as we talked about for like several slides back, path attributes are the magic tool for extending everything.
Yeah, in terms of what do you do? Well, we're just going to shove this stuff into an existing container. This should be familiar to anybody who's done other working groups where, well, this just can go into a sub TLV, and well, we'll get away with no murder. So what do we actually do here for carrying multi-protocol stuff? Well, part of the things that was created for BGP is not only we could carry the address family in there, we're also going to add the idea of a subsequent address family. In the original version of multi-protocol BGP, this was because not only were we signaling V4, V6, but we were also having a lot of fun multicast stuff going on during this era. So the original use case for the SAFI was, is this a unicast topology? Is this a multicast topology? Later on, we got very clever and started doing other things like VPNs, and some people are very unhappy about that, but that's where we ended up. As part of this field, we're also going to carry along not only the AFI-SAFI, but we're going to carry around the next top itself, and then we start carrying around the not IPv4 reachability.
So remember, transitive, non-transitive, turns out that it's really important for everybody along the path of the update to understand how to do the forwarding for the routes. So it's non-transitive, meaning that everybody is really required to be able to decode it for it to propagate. This brings in sort of like the other important extensibility piece, which is how do two BGP speakers know that they can talk a particular AFI-SAFI to one another? They do it with capabilities. What's a capability? It's a thing that you use to advertise support for an extension. And almost all the time, it's not required in the capabilities spec that they be exchanged bilaterally, but that is usually the case for most of them. They're encoded into that. Remember back at the beginning, we said there was an optional parameters field. There's essentially only one optional parameter, and that is the capabilities parameter. And the reason for that is kind of lost in the mist of time, and I don't want to dive into it.
It's all John's fault.
Yeah, I'm sorry. It's not all my fault. It's just half my fault. And yeah, why don't you talk to the annoying bit there?
Um, so one of the gotchas is that the clarity about what happens if things pop up more than once. What's the level of clarity, especially since one of the irks that got put in the protocols, and it's like you're making up as you go along. This is again a piece of the lesson here. You can get away with doing something that makes sense at the time, but whatever choice you make, the inconsistencies are going to bother you later on. And one of the things that capabilities have is that you can encode them either as one optional parameter capability with the vector of the capabilities in it, or potentially more than one of these things. This leaves ambiguity about what happens if a given capability is present more than once. What does it actually mean?
Actually, it's not on the slide, but the moral of the story for me about that particular annoyance is that that crept in because the original capability spec wasn't prescriptive enough about that exact question. So one set of implementers implemented it one way with all the stuff implemented under one capability, and another set of implementers decided to repeat the capability again and again. And by the time we worked out that there were these two different behaviors in the field, it was kind of too late to go back and fix it. So we just permitted it both in the spec. So be prescriptive.
And speaking of prescriptive, what goes inside of the multi-protocol capability? Well, it's an AFI, SAFI, and there's this reserved thing. And one of the things that we know as designers of protocols in IETF, reserved often means here can go extensions for the future, if you're very lucky. And the problem that we've seen over the history of BGP is that sometimes if you're very careful about your text for this, and people are careful in implementations, reserved fields can actually be used, but sometimes the reserved fields are not carefully set aside, and the extension tries to make use of it, and then it explodes. So unlike a lot of other protocols that we have, since the blast radius is the internet, even if people are not technically following the specifications, well, we have to adjust versus reality.
Yeah, BGP as it was originally conceived and deployed had a very similar, or a very simple rather, deployment model, which is for IBGP within an AS, every router simply talked to every other router, and they all told each other all of their routes, and life was good. As you can probably imagine, when you get up to even a few hundred routers in your AS, that starts to be a real pain every time you want to add a router to your network. And furthermore, when you consider that the router needs to, like for every route I've got, if I've got 100 neighbors, I have to copy it out 100 times out of the same interface. It makes me sad.
So what are you going to do about that? We have to have a couple of core properties anytime we try to remove this sort of no full connection where everybody gets everybody else's routes. Thing number one, we have to do something about loops. If we're going to add another thing that routes can pass through, how do you make sure they don't ping pong back and forth with each other? So each of the mechanisms we could talk about have some flavor of an extension to handle additional loops. And just as importantly, as we were talking about the incremental deployment of new things, if we're going to change these things, how does that influence the path selection? You're now adding additional things that it has to tie break on.
So I think the first scaling thing that was introduced, and my name is on this RFC, but it's not due to me. I just came along later and helped fix it. Is the idea of taking an AS and breaking it up into a bunch of sub ASs. And within one of these sub ASs, you just have regular IBGP semantics. And in between the ASs, you have essentially eBGP semantics. And it's just recursion. Recursion is great as a recursive data structure. I think, well, you can argue various reasons why this didn't take off more than it did, but I think the biggest one is that it kind of requires a flag day to deploy, and turns out that people are allergic to flag days for good reasons.
Yep, and one of the things this also illustrates is that AS path had additional types that go in here. This was the first example of extension. As John pointed out, this didn't end up being super popular, even though some very large service providers do make use of it, and it does have some very nice properties for allowing you to keep things basically in house. Where people went to eventually, as the popular thing, was route reflection. The nice thing about this, as top of the list, as John's mentioning, well, you don't want to have to scale out the entire network and change all your configuration. Well, you can insert route reflectors basically in the middle of your network with very little change to everything else. The reflector becomes a transparent thing. Everything still thinks it's just IBGP, and the reflectors are the ones that have to understand the additional complexity. Well, it meant that we solved a couple of our problems. We no longer have to configure a peering session for a full mesh. The gotcha is that it actually hides paths. Sometimes this can be a feature. So instead of having for n routers n copies of the route, well, you have a subset of that. If that's fine for your forwarding diversity, great. But there's an awful lot of reasons that people want to add additional paths in there. Loop prevention got solved, unlike the AS pathing for confederations, by adding a new cluster list in there. And as a side effect of that, we also add on a originator ID so that BGP can do its normal path selection that would normally tiebreak at the router ID step based on how this thing had gotten added on, because it's not directly connected anymore.
You talk to this one.
So in terms of the reflectors, we talked about some of these features are IBGP. The headaches that we have is that, well, what do we want to pass through the network? What do we want to actually get around the network? For a reflector, the reflector has to understand each of the things it talks to. We're not in that full mesh anymore. So that means that if you want to add on a new feature, path attributes work fine. When we add on new address families, this means that the reflector is no longer a dumb distributor. It now actually has to participate and understand enough of this to do the reflection. One of the other headaches that we have, and based on this is a slightly older slide deck, we also have some issues with what path attributes need to go to the various places of your network. We no longer get quite the same ability to scope them, so we now have to worry about attribute escape. What features are internal only versus features that external only.
Yeah, so we invented this great thing called route reflectors that gave us scalability and how the network is configured, and gave us path hidings, which gave us storage complexity scaling and communication complexity scaling, but it lost us path diversity. So then we had to invent a way to undo some of that. And it's this additional feature called add paths, which essentially, at a very high level, remember the NLRI is the key that we use on our database. It basically just extends that key with a thing called a path identifier, which is an opaque number.
So high-level summary. We started just carrying IPv4. We obviously carry a lot more things these days, not just V6, VPN families. We carry link state in there, not only just carrying the IGP into BGP, but we also have a link state vector routing working group that's based on that technology. We're also getting a discussion now of the CATS working group for carrying compute information in terms of compute capacity. Extensibility mechanisms were built in from day one, and we managed to leverage them. So for people that are looking to prune the protocols down to the smallest possible thing, I have great sympathies for you, but we have these sort of historical pressures that show us that they can actually be a necessary and helpful thing.
Yeah, what else? Yeah, that's really it. I got nothing else.
Yeah, scoping is very important. So one of the things you'll be seeing worked out of IDR right now is discussions about attribute escape. This is where things that are maybe your VPN stuff that's getting out on the internet and causing hilarity. It's part of our security discussions. One of the other bigger discussions that this is moving into is how do we actually continue adding things in the BGP and making sure that we don't break the popular things that you care about. Internet service providers don't want the VPN feature of the day crashing their network. And a lot of our discussion on Thursday is going to go over the how do we shovel additional things in the BGP, and when is that good, when is that bad? But
The answer is when it's good when it's my feature and it's bad when it's your feature.
Yep. And if you're trying to ship RFCs for a living, well, certainly BGP is a popular place to try to do that. DNS being the other one. And that said, sort of like the final point is, going through the history of BGP, you get to see all these strange encoding issues. You're seeing history. We got there one step at a time. Eventually, as the new coder, you're wanting to say, oh, why did we get here? This is making for messy code, and more unfortunately, this makes for bugs.
Now, BGP is kind of the English grammar of protocols. It's it shows its multiple inheritance and its history in all of its irregularities, and that's what makes it beautiful.
Yeah, so we're not trying to cover anything else further in the protocol. These are all the high-level details, some of the things that actually have helped it grow. Certainly willing to, if you have questions for us, we're willing to take them at this point. I think we have a little bit of time for
I think we have 10
microphone.
more minutes in the session time, I believe, and we'll, as Jeff said, we'll also be. I don't have any place to run to, so.
Yep. So thank you for your attention. Microphone.
Hi, my name is Etu. I'm from Exclusive Networks, distributor of vendors. My question is regarding the route reflectors. Very good stuff. The problem that I have, I think, which you covered here, is that if you have two reflectors, right? Let's say a prefix is only available on one, A, not available on B. Same kind, right? You're trying to inject the prefix into the same client, sending it through the other reflector. Is that something that you guys are working on?
So it's the general expectation that the reflectors, just like all IBGP, you should have consistency. So if you have some destination A that is present on one but not everywhere else, it's suggesting either a bug or suggesting that you may have policy configured in your IBGP, which is not usually what you want to do.
That's the problem. Is that with IBGP you can't change, you can't send it again because it's.
This is BGP. You can throw policy wherever you want to, and it will usually do you wrong.
Right.
So.
The other thing I would point out is that BGP, just like most of our routing protocols, is an eventually consistent protocol, which means that any given time you're not probably going to have a consistent cut across your whole AS. So at any given moment in time, it's likely that you're going to have a slightly different set of routes that you've learned from the first reflector and the second reflector just because of timing issues. So just because right now I only know route foo from that router over there doesn't mean that, in a few microseconds later, I'm not going to also know it from that reflector over there. I'm not sure if that speaks to your question that you have in mind.
It's totally different.
Okay.
Reflectors on its own. So
Okay.
I'll figure it out.
Right.
We'll come at the end of the chapter.
Yeah.
Yep.
Maglosse, any plans for running BGP over quick?
Easy leading question. We'll talk about
Did
this.
Jeff pay you to ask that?
We'll be talking about this very briefly on Thursday, not in a lot of detail, but yes, so solving some of the sins of TCP, we're talking about that. TLS is sometimes a misfeature. We'll talk about that in terms of security, sometimes bad for you on Thursday. But the important thing that I think Quick is going to give us, and Jeff Tansura, myself, Alvaro, and Ying Jitnan are working on a spec for this. For us, the key things are, not just running TLS. Sometimes security is a good thing rather than a bad thing. Sometimes, you could be faster, but BGP is a pretty slow protocol. Trying to apply rocket fuel to make it go faster is going to make your CPU eat the routes any faster. Where it's sort of an exciting thing, and what's in the main part of the spec that we have is these AFI-SAFIs that we have for the multi-protocol stuff are no longer one monolithic data stream. We now can split them up using the quick streams so that they're kept on the side, and it simplifies our error handling.
Jim Reed, a BGP virgin. I just take a previous point about BGP over QUIC. Surely it should be BGP over HTTP. I thought that's what everything was being done these days. Anyway, I digress. My question is really for naive types like myself. Is there any guides for implementers? And I've been that in both senses, people actually writing the code and also for people configuring BGP in their systems as to avoiding the obvious mistakes and avoiding doing the stupid things that could cause the obvious problems that you just alluded to in your talk. Great talk, by the way, much appreciated.
Go ahead, take a stab. I can do it too.
Yeah, I mean, towards coders, I guess we sort of tried to hit the high level bits in this deck. I don't know.
I think it'd be great if this was captured somewhere in a more formal mechanism, perhaps even as a best practice BGP RFC or something like
I
that.
have a thing for you. So if you talk to Tobias Feibig, who is at the conference, he has agreed to take up the work for BCP 194, which is a common set of operational things for BGP, where some of the wisdom's trying to be written down. Part of what he's finding is that when you try to boil the ocean, you have to do it a liter at a time. So the challenge is, how do you actually take all these common pieces of wisdom, which are operationally applicable to specific scenarios? BGP is this protocol that's simple, lots of extensions, where you deploy it, how you deploy it, what you use it for, all change the different pieces of this equation. The flexibility makes for complexity. The complexity is what kills you. Most of what we're talking about for network operations in general, and this is great for like the NANOG and RIPE crowds, how do you manage complexity in your network? That's the key conversation. The rest of it is dealing with the crazy vendors who are doing the incompatible versions of some flavor of the feature.
Okay, that's great. Thanks very much.
Hi, I'm Paul Gear from just down the road. You spoke about responsible use of reserved fields. What does that look like in practical terms? And is it that, does it boil down to TLDR always put zeros there? Or is it a bit more nuanced than that?
I'm going to pick one very easy one. One that John tried to do as part of working on the 7606 work for error handling. We mentioned this attribute flag field here. There's 4 bits that are defined. They're the top 4 bits. The bottom 4 are technically reserved. That means you theoretically can put stuff in there. And when John was working with all the other people trying to solve how do we deploy these extensible things for error handling, there's this idea that we could add a signal bit in there that says that this update has had something corrected in it. And when some of the very first bits of prototype code went in, got deployed across the internet, about 5% of the routers on the internet saw this extra bit getting set on occasion, and it would throw the session away. You're supposed to ignore it, and it didn't, and it was operationally disruptive. And anybody who's looked at the various BGP experiments across the years, of which there are people in this conference that run, and some of the right people have done it in a more sociable way than some of the other people that do BGP experiments. You find that sometimes things will just explode even when you're trying to do something that's within the protocol.
So I think that in the QUIC community, they have the idea that if there's something that is reserved and must be ignored on receipt, it's actually a good idea to exercise that. And, and so of course, we didn't have that idea. We never exercised it. And something you don't exercise is something that doesn't work. So yeah, I think that, the TLDR that you said is probably right, is that things that haven't been exercised for decades are probably burned at this point, unless proven otherwise.
Yeah, and the thing that we're sort of desperately lacking is a planetary-wide conformance suite for BGP. Theoretically, everybody should pass the same safety tests. That's not universally true.
Thomas Eckert. Yeah, thanks a lot for this. I'm not sure that aspirational deep dive was anywhere close. I would call it a great cheat sheet, right? So this would be a great wiki page, kind of what's this damn term about BGP? I'm sure I'll find it on the cheat sheet, and that point me to some RFC. Did you ever write some RFC like that, by the way? Hitchhiker's Guide. Okay. So the one thing I was missing. So if this is directed to implementers, I think it's mostly the on-the-wire stuff for the implementers. So at one point in time when I was looking into BGP, There was this magic, what is it, 14 rule set, best path
Yeah.
selection. There seems to be some standard, and then the reality seems to be not only a varying degree of messing around and changing that, but also a seemingly not standardized degree of flexibility of being able
Yeah.
to mess around and change that. So if you buy one vendor, you are able to do some cool policy, and another vendor you may be able to do another cool policy that changes the best path calculation. So what's kind of the best IETF state of messing around with the best path in terms of all the things you should be able to do things you shouldn't do but will need to do.
So, sorry?
Could I quickly pop in for a second and say, if you enjoyed this, make sure you come back on Thursday at 5:45 to see part 2, which has even more detail related to.
A little bit. So, Torles, to answer your very specific point, one of the dangers of BGP is that we have extensions. There's no requirement for these things to be consistently deployed. So if you have, base 4271 plus extensions A, B, C, and D, and some of these impact, the route selection, well, that means that you have to decide what the set ends up being. You're correct. It's not all in one spot. Most of the deep things are in the base specification. Several of the specifications add in for their extension, individual things. And usually, and then this is again one of the hidden rules, if you're going to deploy that feature, that means that you have to have a consistent deployment within your domain. And that's not written down very well.
Right, and that's why I was saying, right, rather than trying to hopelessly try to specify upfront all the details, it's maybe, the required flexibility in messing around with the policy so that even if you have different implementations, you can fix them up so that you do get across different vendors a consistent best path with a specific set of extensions.
Yeah,
and I haven't seen that type of
Yep.
policy language, for example, policy language to specify kind of my best path calculation, right? So that would be, of course, also another way to specify how it should be. But in the first place, it should be a way that you do know you will have the flexibility.
Right. There have been a couple of attempts to fix this in a general way. There have been at least 4 attempts to fix this in a general way, and none of them has, sort of gained universal traction. One thing that makes it somewhat more pain or less painful, let's say, is that networks that are hop by hop routed edge to edge are a lot less common than they were when 4271 was written, and tunneled forwarding makes a lot of the consistency requirements weaker.
Yeah. And like the final comment, we have this nice formal methods group that has been spawned for IETF. Maybe this is a piece that they can dig their teeth into of, can you model this?
I would like to thank John and Jeff for great talk. I think we should have more than this. I know the number 2 is coming. I would like to encourage you to do 3, 4, and 5. Specifically, in IETF, we always talk about the internet, right? 80% of BGP speakers today are in data centers. They're not on internet. Data center BGP has somewhat different semantics. And again, thanks to flexibility and scalability of BGP, it is the protocol of choice. So I think it would be very, very useful for people around to better understand really BGP in data center semantics.
That's a great
And thank
point.
you again.
Eric Green first. Thanks again for the presentation. Very interesting. Always amazing to see BGP control protocol used to transfer whatever, right? So I'm expecting quick over BGP, not the other way around first. More seriously, I'm more and more concerned about the complexity of all the draft updating, I mean, RSC updating up there. Is there any idea, appetite to get a RSC 2470 bis? And how long will it be if we get everything there?
I would like
not
to
directing
call
to anybody, right?
Out of the way.
My name is Sue Hares. I've been a long chair. Look, I've had 4 times. It sounds funny. I have proposed a BIS, worked on a BIS, worked with the 4271, which is actually the 3rd variant. If you really want to stop all of the work to do it, I know where all the bones are buried. But every time I've gone to do it, I've gone to the people and said, okay, this is what it takes to do Abyss. This is how much work it's going to do. And this is what you're going to have to give up. And you will have to give up changes that people seem to need. So this is our possible, but do understand the 4171 BIS is I'm trying to find a good adage. It is a large bag that you will have to carry around, and it won't necessarily give you anything extra. It'll make writing this stuff easy. And, you know, the chairs talk about it sometimes, but let me tell you, I haven't yet seen people want to stop their forward progress.
Yeah, we'd love to do it, I think. But it's, yeah, it's not only do you have to rebuild the jet plane in flight, but you have to take the mechanics that are, you know, building revenue, you know, features and have them rebuild the jet plane instead. So far, the appetite hasn't been there.
Yeah, the thing that we should be doing, and this is true across IETF in general, it'd be nice to have a roadmap of the various documents, how they relate to each other. There's a nice data tracker feature that gives you a graph of things, and when you poke BGP on that, you better have a very large screen. And that's really our problem here is, you know, again, nobody has to support everything. This is everybody's favorite thing to extend aside from DNS. So our challenge is how do we actually make it easy to navigate things? And you know what we're trying to do, as an example, like the attribute escape document I'm doing, we're taking some time to write down the gotchas. You know, what are the things that are problematic about BGP that may not be clear from the base specs?
There you go. Yeah, thank you for volunteering. So our queue is empty, and I think we're 5 minutes over. So thank you all so much for coming. Thank you for your attention. Please consider coming on Thursday.
See you Thursday.
And I guess once again, I'll remind people about Thursday. And also, if you have any thoughts of future topics for technology deep dives, please send them to me or something like that. Preferably not now, because I just drank 2 coffees and 1 of these.
Excellent.